All right, so for the last few classes, we've been talking about RS-232 and serial and those types of things. Right? I've showed you guys the ASCII tables, and overall, it's been kind of interesting, I think, kind of the coding data and those types of stuff. Um, but we're still kind of diving into it a little bit. And with that goes the lovely world of decoding. And we attempted to decode last class, and I horribly failed you guys. Not gonna lie, horribly failed. However, I've had some time, I've looked at things again, refreshed it in my brain, and I figured out the problems we were having. But we'll get there in a minute. All right, so we're going to send my lovely letter. I've been going with A. I don't know why I've been going with A, but I've just been going with A. So we've got the oscilloscope in trigger mode. We're waiting for data, and when I hit enter, it's going to send it. We can tell by looking at the top left-hand corner that we did stop. All right, and we've got our data. Now we have to find it. All right, now, first thing I like to point out again is our time frame. All right, I have gone outside the realm of defaults here. All right, I am transmitting at a baud rate of 100 bits per second, just to make our life easy. All right, so basically 1 millisecond is every bit. All right, and that is why we are very nicely lining up color with the dot lines here. All right, we're not in between them, those types of things. We're just like perfectly lined up just to make our life a little bit easier, which for decoding purposes, it just makes our life that much simpler. All right. Now, last class, I was talking to you guys, and we're trying to decode this, and I'm like, why isn't it working? And I got very pressed. It was surprising. Then it doesn't work for your students. You're supposed to know what you're doing. But, so I don't decode this very often, so it's one of the reasons that I have to refresh in my mind every semester. But anyway, so I was looking at this, and I was saying, if you remember, we were talking about serial and how it's normally inverted logic. So up is 0, down is 1. So I was saying, 1 0 1 1 0 1 1 0 0 1 0, and we have our start bit, and then this last one's our stop bit. So there is our 8 data bits: 2 4 6 8. So I was saying, okay, this is either 0 1 1 0 0 1 1 1 1 0 0 1, which if we bring in our lovely calculator, 0 1 1 0 1 0 0 1. I was saying that equals a decimal of 105, and if we look at the ASCII table, if I can get rid of this add, there we go. 105 is a little I. That is not what I was, right? So I was like, okay, let's invert this. So instead of zeros, let's make it 1. So I said it's now 1 0 0 1 0. No, sorry. 1 0 0 0 0 1 1 0. That gives me a decimal 134. And again, 134 off this page, not the little a that I sent. It should have been 97. Like, okay. And we have to mirror it, right? Most significant bit versus least significant bit. Which one did we send first? So if we mirror, this is what we did last class. We were mirroring things. So we said, okay, it's 1 0 0 1 1 1 1 0. That comes out to 158. Still not the 97. Like, you gotta be kidding me. All right. So the last one we can have is mirrored and inverted. So backwards and flip my numbers. So that would be 0 1 1 0 0 0 0 1, and that finally gets me to the 97. All right. So what that tells us is A, it sent this as LSB. All right, so least significant bit first. So that means of our string of characters, which would have been, again, 0, 1, 1, 0, 0, 0, 0, 1. All right, it sent the last one first. So that'd be our first bit. This would be our last bit. All right, so it actually sent it backwards. All right. Also, it tells me that serial in the world of TTL is not inverted logic. 1 is a high and a 0 is a low. All right, and that was what I was really screwing up last class. I kept thinking it was inverted. Like, it's inverted backwards, and it is not. All right, so that was the main problem that I was having last class. But I thought TTL was inverted, and it wasn't. So I fixed it. All right, I got back to you guys with how the whole problem was supposed to be solved. But anyway, and then I went home, and I told you guys I meant to bring one of these in. So here I have a little USB to DB9 connector. All right, so these, they are very, very available. I actually have two of them up here. I have this dark blue one that I have electrical tape back together. I don't remember why I electrical taped it back together, but I did. And then I have a teal one that's actually plugged into the USB port right now. And before class, I actually took some screenshots for you guys. So here I have, let me clear my screen off, make my life a little bit easier. So here I have the blue connector, and here I have the Arduino, which is the data capture. And what differences do you guys think?
The one on top goes in the negatives.
Excellent. The one on top goes in the negative. So remember we talked about TTL, when we were talking dealing with transistor logic, we don't go negative. It's just 0 to 5 volts. All right. Where with the RS-232 standard, it does go negative. So that is a big difference. All right. Any other differences you see? Nothing? All right. There's one more difference. As I was just talking about. Inverted. All right. The Arduino, it's held high by default. So you can see right here, this is where we're held. Where the RS-232, we're held low. All right. So again, 232 standard, inverted logic. 0 is a high, 1 is a low. All right. With TTL, it's not. All right. So those are our two big differences there. Now, does anyone see any differences? And this is where you guys go, and is he screwing with us, or is there an actual difference between these? Oh no, I got this button. There we go. Mind you, I didn't change any settings in between these things. Go ahead.
Inverted.
Okay, it is inverted. Yep, it's still inverted. I guess I really should be comparing the other two. Yeah, I don't know how to drink this nicely, so we'll go back to, we'll just go back to Arduino on this one. Anything else? There's one other difference. Not a good difference either. I'll let you guys stare at that for a minute while I said. All right, does anyone come up with it? No? Timing is off. All right, if you look at this, everything lines up in the background on the oscilloscope. There we go. Everything in the background lines up, right? We've got right here in the middle, crosshair lined up. If we look at our, they're not lined up. What's going? Why did you change on me? What changed? Oh, this is teal. I want the teal. I want the blue. I want the teal. There we go. Now everything lines up. All right. But if we look in the background, like dotted lines, they line up. Dotted lines line up. Dotted lines line up. You know, dotted lines line up everywhere. But yet the serial data doesn't. All right. So we've got a little bit of an issue going on there. And if I go to the Arduino logic, right, and I do some quick measurements, and I just, go from line to line roughly. All right, there we go. You can see down here in the bottom, frequency is about 1 kilohertz. All right, 1,000 bits per second. That's exactly what I was expecting. All right, it's a little off because I can't quite click properly, but close enough. All right. Now, this next one's going to take me a minute to get set up, so let's just pause the recording. All right, now that we've got the data, we're going to take measurement again. If I go from here to there roughly, you'll notice again my frequency now is 1.2 kilohertz. All right, so it is sending data quicker than it's supposed to. All right, which I find very interesting. All right, I thought that this was my problem child at home. I really thought this was my serial adapter that didn't work. Now I'm thinking it's a teal one. All right, I think it's sending data too quickly, and it's not like, oh, it's like 0.001, too quick. No, it's 50% quicker than it's supposed to be sending, right? 200 kilohertz. That's how much quicker it's sending data. So you can very easily see if you're sending a lot of data, how over time it's going to get its bits off. All right, so that can cause a little bit of a problem. So as long as depending on how the asynchronous serial is set up and you got your communication working, this may or may not cause problems with being able to transmit information out to the device. So if you're ever having problems with a serial adapter, maybe bring an oscilloscope, plug it up, and see if you're actually getting the signals that you're expecting. All right. So in this case, I was expecting it to be low, go high, come back. We are at 2 volts per little dividend here, so we've got 5, 10, 12 and a half. All right, you guys remember what the voltage is that we're allowed to do our RS-232? There you go, 25 and 25. All right, so I believe that this is outputting 25 volts. All right, I actually could take an oscilloscope to it, a voltmeter to it. Actually, let's just do this. What's going to do? I'm not saying it's 5 volts. That was not what I was expecting. But that's it. Anyway, it's just kind of interesting to me to look at that and go, okay, this is the voltages we're seeing or not seeing, those types of things. So it's just a little test that you guys can do. Oscilloscopes are great troubleshooting tools. Obviously, they're not perfect. All right, now, I'm also going to say that the little oscilloscope we're using here today, about $70. Not a very expensive tool. Obviously, the software could use some love. There is other open source software out there that I want to try with this to see if it works any better. So that is on my list of things to do someday, but I haven't gotten there yet. So anyway, it is a great tool. It can be a very pain in the butt tool to work with if the software's not working. Having a really nice, good oscilloscope that you guys are going to see up in HEC 213, I believe it is. The wriggles that we've got up there, even those aren't really nice. I mean, as far as I'm concerned, they're really nice. I'd love to have one of those. Take it home. But I don't have that. So you got a lot of give and take going on here. So a little $70 one gets the job done. Sometimes you have to manually trigger it. All right. Funny thing is, I've learned with this one, if I send it a whole bunch of A's, go ahead and put this back into single trigger mode. I just send it a whole bunch. I'm saying 30 A's. It triggers just fine. But for some odd reason, sending one A, it doesn't detect with this serial adapter. With my Arduino, it detects it just fine. Not changing any other settings. So it's kind of interesting to me to look at that and know what's going on. But anyway, cheap oscilloscope, they do get the job done. Kind of an interesting one there. So any last questions on this before we get into a lab? No? All right. So that's a little demo decoding information from serial. And we could decode this whole thing, right? I guess we could just do that. If I just go find something. Now, this is going to be kind of hard to decode at this point because I don't have a starting point, right? I'm just in the middle of a serial data stream here. So it's where is that starting point? All right. Now, I guess let's just go A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. There we go. Let's try sending that and seeing if it's gonna get it. Hey, it did. All right, so now we actually have both the beginning and the end. So that's actually kind of nice. So we could actually just zoom in on this. All right, how many start-stop bits do we have? If I'm telling you this is 1,000 baud rate, 8 data bits, parity is none, stop bits is 1, flow control is none. We need to talk about flow control. That's fine. All right, where does my data begin and end? Anybody? I mean, obviously, I'm hoping, right here is the first transmission. What's the first thing it sends? A what bit? Start bit, guys. All right. So it sends the start bit. And then I told you how many data bits do we have? 8, right? All right. So we've got 1, 2, 3. I did that horribly. 4, 5, 6, 7, 8. So there's the end of our data. All right. And then we have 1, 2, 3, 4. 4. I think that's 4. 5, 6, 7, 8. Okay. And then we go high. Anyway, you could decode this. You could go through this whole process and decode it, and it would be all hunky-dory. All right? I don't need to do that for you guys right now. So let's just go. Let's get in the lab. What I really wanted to point out to you was, in theory, one of these bits is changing every time we repeat. Because we went A, which is 97, B is 98, so it should have, changed 1 bit, or maybe 2 bits because 1 was. But anyway. All right, anyway, let's go ahead and get into the lab.